Hello everyone, this is Dr. Surendra Yanurkar working in Department of Electronics at Sri Shivaji College, Parvani. In previous video, we learn about BJT and different types of biasing. In today's video, we learn about common emitter amplifier circuit for faithful amplification and its biasing. After that, by using output characteristics, how to draw DC load line, and from the load line how to locate Q point so that CE circuit gets faithful amplification. Look at this figure. This is a figure of C amplifier circuit. In the circuit, BJT is used as an amplifier. Then it is biased in such a way that base emitter junction is forward bias and collector base junction gets reverse bias. And once we apply the DC voltage source to the BJT, then the current and the voltages are established in the circuit. And after biasing the BJT in the active region, if we apply the sine wave as an input, then we should get the amplified signal at the output. But whether we will get the proper amplified output or not, that depends on how well the BJT is biased in the active region. So let us understand it through the DC load line and quiescent point of the C amplifier circuit. Now look at this figure or this circuit. This circuit is a common emitter amplifier circuit with a NPN transistor, and here this configuration is used for amplification because high current amplification is possible for this configuration. Let us see, this is the NPN transistor. VBB and VCC are the biasing potential. RB is the resistance connected in the series with the base, and RL is the resistance connected in series with the collector. You can see emitter is common to both the input side and to the output side. Therefore, we call as this circuit is a common emitter configuration or common emitter amplifier. The input voltage is VB, the input current is IB, the output voltage is VC, and the output current is IC. Now we want to amplify the weak input signal faithfully. By faithfully means the amplification of input signal without any distortion. If we apply any input signal here, then we want the amplified input signal without any distortion. For example, if the input signal sinusoidal, then we want amplified output signal to be sinusoidal. We don't want any portion of this waveform to be clipped. This is what we mean by faithful amplification of the input signal. For the purpose of faithful amplification, we need to find operating point for the circuit, and the operating point which is located on the DC load line. In case of output operating point, the intersection of the load line with the transistor output characteristics for particular value of base current, that is IB, gives the operating point. So for this, first requirement is to draw DC load line. So DC load line is straight line joining cutoff and saturation point for the CE circuit. Now for calculating this cutoff and saturation point, apply Kirchhoff's voltage law for the output closed loop. See, that is A, B, C, D, A. Here VCC is a battery. If we go from negative to positive, taken as positive sign as per the algebraic sign rule, the current and loop direction is opposite to each other. So we have right negative sign for IR drop across RL, that is minus IC into RL. Minus VC is equal to 0. Therefore, we can write this equation like this: IC is equal to VCC divided by RL minus VC divided by RL. Now consider the following two particular cases. When IC is equal to 0, it gives VC is equal to VCC. This gives the first point called cutoff point, denoted as A, and when VC is equal to 0, it gives IC is equal to VCC divided by RL. This gives the second point called saturation point B. The above equation can be written as IC is equal to minus VC divided by RL plus VCC divided by RL. It gives a linear equation similar to Y is equal to minus mx plus c. This equation is a straight line equation. Therefore, slope m is equal to minus 1 by RL. Now look at this figure. This is the output characteristics for common emitter configuration, in which collector current IC is plotted against collector to emitter voltage, that is VC, simply for different constant base current see in the figure. So different output curves is plotted in this graph. See, this region is a cutoff region, and in that region transistor is in cutoff mode, or transistor is fully off because both junction of transistor is reverse biased. Now this region is the saturation region. In this region, transistor is on and gives maximum current, that is called saturation current. Now look, this region is active region of the transistor. In that region, operating point is located. Now we find the 2 points, that is cutoff and saturation point, that will locate along x-axis and y-axis respectively. When IC is equal to 0, then VCE is equal to VCC. This point is cutoff point denoted as B, and when VC is equal to 0, then IC is equal to VCC divided by RL. So this point is saturation point denoted as A. Now straight line is drawn from this point A and point B. This is called as DC load line of CE circuit. Now see how to find operating point from the output characteristics and DC load line. Now a point on the DC load line which represents the value of IC and VCE that exists in a transistor circuit when no input signal is applied is called as operating point, also named as quiescent or silent point, or shortly called as Q point. So as it is the point on the output curve when transistor is silent, that is in the absence of input signal. Let us see this figure. We have draw. This is output curve and this is a load line for a transistor in the absence of input signal. The intersection of load line with output curve at the point Q. This is the Q point of a transistor. If we draw the tangent along x-axis and y-axis, it gives the coordinate of Q point denoted as C and D in this figure. So in this video we discuss about C amplifier circuit, its biasing, so that this circuit gives faithful amplification. Also how to draw DC load line for this circuit, and from the DC load line and output characteristics how to locate operating point, or we say that Q point. In next video, if the Q point located near the cutoff point and saturation point, then what happened? Also how we will get maximum undistorted output for the circuit. Thanks for watching this video.